Ask someone to draw a picture of a planet, and odds are it will be this one. It is the 6th planet out from the Sun, and the 2nd largest in our solar system. It is, of course, Saturn, a world encircled not only in majestic rings, but in an array of moons that have been likened to a solar system in miniature. In 1997, an international mission was launched to Saturn that would, for the first time, attempt to place an orbiting spacecraft around the planet and land a probe on a moon in the outer solar system. But this was a mission that had to fight its way to the launch pad.
We're going to have to operate under a very strict fund ceiling, one that is imposed by Congress.
This will require doing business in a drastically different way than we've done before.
It took a lot of time, a lot of negotiating, a lot of compromises to make that work.
The first time I saw the spacecraft together, when we stacked without the blankets, we were without words standing out there.
The journey to Saturn would take 7 long years. But the success or failure of being captured into orbit depended on what would happen during just 3 hours.
Go ahead, telecom.
The engine better fire, otherwise we'll end with a flyby.
Copy. ACS fall protection.
I think as a ring scientist, my greatest concern was really crossing through that gap in the F and G rings. It would only have taken one marble-sized particle in the wrong place in the spacecraft to perhaps have ended the mission.
So I would lie in bed at night and think about, what other test should we do? What other question should I be asking? What should we be poking at here that we haven't done yet?
SFE, SOI systems.
We chased everything that could go wrong down the rabbit hole. We went down every path of, if this goes wrong, what do we do? If that goes wrong, what do we do?
And this was one of those moments where you're either in orbit or you're a billion-dollar flyby.
Closest approach is just a little over 2 minutes away. Predicted temps today, minus 226 degrees Fahrenheit, winds of 1,100 miles per hour, hurricanes the size of the Earth. Cassini would do well to batten down the hatches.
Saturn was once but a single bright point of light in the night sky. But in 1610, Galileo peered through his telescope and saw something else. On either side of the planet, he thought, there might be moons. 2 years later, Galileo looked again. To his astonishment, the 2 objects had disappeared. Another 2 years passed, and Galileo again trained his telescope on Saturn. The puzzling bulges had returned. This drawing shows how close Galileo came to solving the riddle. But he went to his grave without ever knowing the answer. A half-century would pass before the Dutch scientist Christian Huygens realized the bulges were rings. As for their appearing and disappearing, when the rings are viewed from Earth edge on, they all but disappear. As time passed, Saturn came into closer focus. And in 1979, NASA's Pioneer 11 spacecraft gave the world the first close-up look at the planet and its rings.
We received several pictures yesterday afternoon and evening, and we'd like to run through some of those now. This is the one that came in here at about 3 o'clock yesterday afternoon. This is by far the most spectacular picture we have so far. This is raw data. It has not been processed in any way. We can see the big banded planet, and of course the ring system is very prominent in this picture. Also prominent is Saturn's largest moon, Titan, in the upper right-hand corner.
The two Voyager flybys soon followed, offering even more captivating views and discoveries. What these missions found left scientists clamoring to go again, and not just to pass by, but to stay. A blueprint and even some spare parts for just such an adventure already existed. NASA's Galileo mission that sent an orbiter and a probe to Jupiter. Advocates in Europe and the United States argued for a similar mission destined for Saturn, one composed of an international consortium. How such a project with all its complexities could be done, no one really knew. Sorting out roles, responsibilities, and especially funding took the better part of a decade. The European Space Agency offered to build the probe, named Huygens, to land on Saturn's moon Titan. The Italian Space Agency would build the main antenna and communication system. The spacecraft's thrusters and the main engines would be provided by U.S. commercial space companies. And NASA's Jet Propulsion Laboratory signed on to build and fly the spacecraft to be named in honor of the 17th century astronomer Giovanni Cassini. JPL would also provide overall management of the mission. In total, 19 countries would provide hardware, while scientists would come from 26 nations.
Good morning. I want to welcome all of you to JPL and to the beginning of what is going to be clearly a very exciting mission. I know that a lot of you have...
This is the first gathering of Cassini-Huygens scientists and engineers. Their goal, to transform this complex partnership into a functioning team.
Our Congress has had some agony over the program. For a time, it looked as though only Cassini would be approved.
There are layers of unease in the room. The Europeans want to know that they'll be treated as equal partners. And there are also concerns about U.S. reliability, given that NASA has recently dropped out of another partnership.
We're going to have to operate under a very strict fund ceiling, one that is imposed by Congress, and an unyielding schedule. And we all have great challenges.
NASA has already warned that the mission will be canceled if the project strays over its budget. All eyes are on Cassini's first program manager, John Cassani, who has already spoken of eliminating some of the science instruments.
Seriously, I'd like to welcome everybody. Nice to be here. A lot of old friends, a lot of new faces, which I hope will be friends before we're through with this process. Those of you who don't know me will find out a lot in the next couple of years. This will require doing business in a fairly drastically different way than we've done before. We are all going to have to strive for, as we go through this process, is a continual search, as my old friend Gentry Lee used to like to say, for the least unacceptable solution. There are going to have to be compromises. We want to work with you very hard.
This was not what scientists had hoped to hear.
And I think this is a very severe degrade in the capabilities of this mission.
What we did was we did all of these things to finally get down to something that we could afford.
And that sounds to me like a very unwise thing to do. I mean, the essence of this mission is to get data back.
The friction between what scientists want and what engineers can do will be a theme running throughout the lifetime of the mission. So we'll be deciding which of Cassini's 12 different science instruments will have priority at any given time. First up to plead his case is the head of the science radar team, Charles Elachi.
Good morning. I understand from Dennis that the first speaker gets everything he asks for. So be prepared. There is a good thing and a bad thing about the radar. The good thing is that for every Saturn orbit, we need to operate only for 1 hour. You can have all the rest of the time, but 1 hour. The bad thing is that when we turn it on, the lights on the spacecraft will dim. You know, it'll go down.
Representing the needs of the imaging team is its leader, Carolyn Porco.
Stability rates which are lower than that. After all, we know what it will take to image the objects at Saturn that we know are there. My question is, what is it that's there that we don't know, and we want to have a very stable platform and be able to do long exposures? These are issues that ring scientists stay up late at night worrying about.
We are running a bit behind schedule, so we shall skip the coffee break, but there is still coffee for those who can't survive.
One after another, the science teams take to the podium to make their pitches and at times to express their displeasure.
Okay, this is one of the smaller teams, and I suppose one of the smaller instruments, although perhaps not as small as the project might like. I'm afraid I have to say that we have to have an instrument that performs best within the planetary environment. So life is not as simple as perhaps some people have seen it.
The other challenge that we've had here is a recognition over the past few months that the...
Hoping to resolve these conflicts, Cassani offers up an unexpected plan to put the scientists more in control.
Spacecraft, we need to incentivize you to do the best job of making the best estimates of what it's going to cost at the time of confirmation. And then
instead of having decisions made from the top down, Cassani proposes establishing a trading system. Each science team will be given a defined amount of money, mass, power, and data rates. If later they need more of anything, they will have to work with the other teams to solve their problem. The scientists agree to this unusual bartering system. It is the first major step in building a functioning international team.
Any questions? All right, Dennis, thank you.
By the fall of 1997, what had once been just blueprints are now real pieces of hardware. For over the last 6 years, the mission has managed to survive being canceled, something another NASA spacecraft meant to rendezvous with a comet and an asteroid was unable to do. This was part of a new NASA strategy to cut back on large and expensive spacecraft. And there was no disguising Cassini's size. It remains to this day the largest U.S. interplanetary spacecraft ever built. Standing 3 stories tall, when fully loaded, it will weigh 12,500 pounds.
The first time I saw the spacecraft together, when we stacked without the blankets, I must have stood in the visitor gallery for 30 minutes. And I don't know how to describe it. It's not yours anymore. You know, even though I had been intimate with each piece and part of that spacecraft and put it together wire by wire and part by part, to watch it come together as a whole entity was incredible. We were without words standing out there.
Every now and then we'll be working in here and you'll think, wow, this is going to Saturn, and this probe's going to land on Titan, and this is going somewhere where we've never seen things before, and you get goosebumps from it.
The spacecraft has been designed with redundancy as a priority. Each critical system has an identical backup. And its advanced software will allow the spacecraft at times to fly on its own and even self-repair computer glitches. In Cassini's interior are some 22,000 wire connections and more than 7 miles of cabling.
I'm technically an engineering assistant, and what I do is cabling for the spacecraft, and I've been doing it for 20 years. One of the really positive points about our mechanical team is that they never say no. They never seem to tire. They're always up. I don't think we could ask for a better team.
One of the last assembly tasks is to cover this bare spacecraft with blankets. Using machines more often used for fine tailoring than engineering, this reflective material is cut to protect the spacecraft early in the mission when it flies toward the sun. This black fabric will do the opposite, absorbing and retaining heat out at Saturn, where sunlight is only 1% the strength found at Earth. The layers will also provide shielding from micrometeoroids, tiny particles of dust that could damage the spacecraft's electronics. This is tedious work, cutting, stitching, and fitting hundreds of individually measured pieces. It is a job made even more challenging knowing that this intricate space quilt, like all of Cassini's major components, will have to be unmounted for shipping to Florida, where everything will be reassembled again.
We have had less problem with this than I can remember having on any other spacecraft. It's almost scary. Nah, it's beautiful. No problems. No major problems, anyway.
While transforming Cassini from a blueprint into a real spacecraft had gone exceptionally well, getting to the final design had been tortuous. Facing budget cuts, the project was forced to make another, least unacceptable decision. Instead of dropping science instruments, the spacecraft itself was scaled back by eliminating the scan platform, a kind of turntable required by some instruments needing motion. Without the platform, the entire spacecraft will have to rotate to aim at targets, resulting also in less observation time. But all of the science instruments have survived. Operations are now almost complete for the launch of Cassini-Huygens. Already on the launch pad is the Air Force's heavy-lifting Titan 4B. Cassini and the probe have been reassembled. One of the last procedures involves loading onto the spacecraft its power supply. 72 pounds of plutonium encased in what are called radioisotope thermoelectric generators, or mercifully called for short, RTGs. RTGs have been used on previous missions. But recent nuclear power plant accidents and the loss of the Space Shuttle Challenger have heightened public fears of a launch accident spreading nuclear debris. Hoping to stop the launch, anti-nuclear groups file lawsuits, petition the White House, and hold demonstrations at the Kennedy Space Center.
Since this is the last public forum to assure the public that everything is going to be all right, could you do that one last time and use your best argument to persuade perhaps some of your opponents?
RTGs were designed for accident conditions. We've designed them, we've tested them, we've analyzed for it. We've gone through a very lengthy review process. And in fact, these are very safe to use. There's not a risk to the public, even if there is an accident.
Would you all confirm your faith in this mission by telling us how many family members, kids and grandkids you have here watching this launch with you?
Well, I have 30 members of my family here right now, including my 2 granddaughters. There's more on the way.
Right here or on the way?
I don't know if I have more grandchildren on the way, but I have more family on the way. The reality is there's no technology on the horizon that has the promise to be available in the foreseeable future at all that could be used for obtaining power way in outer space where there is effectively very little sunlight. At Saturn, we've got about 1% of what we have here on Earth. We know Cassini is safe. The generator is designed to be robust in the environments. We do not rely on success. We make it compatible with the environments that might be generated, and it's safe. I invited everyone I love to the launch.
Will there be information on the success of this launch, too?
Absolutely. You can find us with a bottle of champagne someplace.
FLC, we have steps 325 and 326 complete. Roger. PA and LCC, 327, 328 on time. PA, Roger.
LCC, Roger.
The Air Force Launch Controller has given a clear to launch. We've got go from the range to proceed with the countdown.
Launch sequence started.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn. Its program is in.
All task force
program is
stations. Launch vehicle reports stage 1 ignition and SRMU jettison.
We have cleared the tower, and the Cassini spacecraft is on its way to Saturn. T plus 20 seconds. All systems are go. Standing by for solid rocket booster separation. And the solid rocket boosters have been jettisoned.
Item 149 and 5150.
All systems go.
All task force stations. Ops engineer. Launch vehicle reports payload bearing jettison.
This launch was, for all practical purposes, perfect. It was just right on target, and the navigation corrections that we normally routinely expect to have to make for these kinds of launches was very small. It was an exceptionally good launch.
But the launch, as good as it was not powerful enough to send Cassini directly to Saturn. To get there, mission designers had long before devised a flight path, using Mother Nature to gain extra boosts of speed by flying by planets, what are called gravity assists. Cassini's route required 2 inward swing-bys at Venus, next back to Earth, then outward to Jupiter, and finally on to Saturn. In all, a journey of over 2 billion miles, lasting nearly 7 years. During the first Venus encounter, Cassini grazed just above the planet's surface, gaining an extra 16,000 miles per hour of speed.
The Cassini spacecraft has now been in space, in flight, for a little over 8 months, and the performance of the spacecraft has been essentially flawless. Typically, on spacecraft like this, of this complexity, there are issues, complications of one sort or another that we have to work with some of our ground-based command capability. For the Cassini spacecraft, this just hasn't happened. It's a remarkable spacecraft.
True enough, but Cassini is not yet a fully complete spacecraft.
We had enough flight software on board at launch to be able to fly the spacecraft, operate it, navigate it, and not a whole lot more than that.
When we launched, we had 7 years to get to Saturn, and we actually completely changed out the computer system twice in flight.
Looks nominal.
We would take the old computer software and then load up the new software in the backup computer, watch it for a while, make sure it was stable, and then we would swap and make the backup the prime computer and make sure it was stable.
As engineers worked on completing Cassini's software, scientists started lobbying to begin using their instruments far ahead of the agreed-upon schedule.
The cartoon. You got to see the cartoon. You got to see the whole thing. So the idle spacecraft is the devil's playground. For the first 3 years, we weren't supposed to do anything. We were supposed to fly a rock. And we were just going to go take the spacecraft, correct it engineering-wise, fly it by Venus a couple times by Earth, and we really weren't going to do much science. And here were the scientists saying, you've got this great spacecraft, everything's working on it, you don't have to check, you don't have to redo your thermal, you don't have to redo this, let's do science. And so I came in one day, and this was on my door. The idle spacecraft is a devil's playground. I swore for years that one of the scientists had put that on my door. It was my boss. He put that on my door.
For the most part, the scientists were accommodated. But the project's priority was first getting safely past the Earth, which occurred in the summer of 1999, giving Cassini another 12,000 miles per hour of speed. The next milestones were passing beyond the orbit of Mars and the region of the asteroid belt. Then came Jupiter, where Cassini saw raging storms, some centuries old. Cassini also teamed up with the venerable Galileo spacecraft to jointly measure Jupiter's magnetosphere, a bubble of charged particles trapped within the planet's magnetic field. At closest approach, Cassini took this image. At that time, the most detailed view of Jupiter ever seen. The Jupiter encounter served as a full dress rehearsal for what awaited at Saturn. It revealed there was work to be done in addressing Cassini's design compromise. The lack of the scan platform that would have allowed simultaneous use of science instruments needing either to move or to be rock steady.
It meant you had to turn the spacecraft every time you wanted to point an instrument someplace. And we had 12 instruments, and each instrument generally had different pointing druthers, if not, in fact, hard and fast pointing requirements. And so it was there was an awful lot of negotiation that went on between the different science teams, the different instrument representatives, in deciding who was going to get to control the pointing of the spacecraft when. It took a lot of time, a lot of negotiating, a lot of compromises to make that work.
Despite this restraint, Cassini could now boast of being the most capable interplanetary spacecraft ever sent out into the solar system. After a journey of nearly 7 years, Cassini and the Huygens probe are nearing Saturn's doorstep. Whether 2 decades of dreaming, planning, building, and undertaking this arduous journey will be rewarded will soon be known. For just ahead is the most dangerous moment that Cassini will face: SOI, Saturn Orbit Insertion. No one is more excited or anxious about this moment than Charles Ilachi. In addition to still being the team lead for Cassini's radar experiment, he now heads JPL.
Cassini is probably one of the most exciting missions ever undertaken by the U.S., and it deserves more credit. So when we come to the orbit insertion, after advocating for it, selling it, building it, then flying it, it was a really very sobering moment. The engine better fire, otherwise we'll end with a flyby. You have to remember that we had the Mars Observer, where when we turned on the engine, the thing disappeared.
11 years before, as Mars Observer was approaching Mars, the spacecraft was commanded to pressurize its propulsion system. The spacecraft was never heard from again. It's believed a massive rupture in the fuel lines occurred, putting the spacecraft into an unrecoverable spin.
It's okay to sit down. Take about 15, 20 minutes. This is Bob Mitchell, who's the project manager.
Okay, well, I think we've got what'll be a rather interesting program laid out here for you this evening. It's certainly going to have a little drama to it. Up this axis I was Delta. Kind of confident, but I was worried, concerned, nervous might be the best word as well.
To slow down enough to be captured by Saturn's gravity, Cassini will have to turn on its seldom-used engine for 96 minutes. Anything less could result in flying past the planet, never to return. The flight path will take Cassini and the probe up through and back down a gap in Saturn's rings. There's worry that there could be particles in these regions large enough to damage or even destroy the spacecraft.
I think as a ring scientist, my greatest concern was really crossing through that gap in the F and G rings. It would only have taken one marble-sized particle in the wrong place in the spacecraft to perhaps have ended the mission. So for me, the most, breathtaking, the heart-stopping time was really crossing through the ring plane.
To reduce the risk, Cassini will fly through the gaps with its high-gain antenna facing forward to act as a shield. During these times, the only signal coming back to Earth will be from a smaller antenna transmitting a single tone. The pitch or frequency of the tone will vary with changes to the spacecraft's speed, what's known as the Doppler effect. This will tell engineers how the spacecraft is performing or not.
But that zero is the reference frequency, the nominal frequency that we would see if there were no burn. So if the motor never ignited, what would happen is this line up here would just go right straight across. And I would lie in bed at night and think about what other test should we do? What other question should I be asking? What should we be poking at here that we haven't done yet? Down here, and this corner right here corresponds to where the burn should end. So there wasn't any single thing that I could point to and say, that thing right there has a fair chance of biting us. There just wasn't anything like that. But when you consider all the things that had to happen or not happen, there were enough of them that the aggregate of them was cause for being nervous. And I was. That would be cause for some level of concern.
SOI was just such a team effort. We chased everything that could go wrong down the rabbit hole. We went down every path of, if this goes wrong, what do we do? If that goes wrong, what do we do? There were 10,000 tests run to put together that insertion.
Something we'd been preparing for 4 or 5 years, testing and testing, awfulizing all of the possible things that could go wrong. And this was one of those moments where you're either in orbit or you're a billion-dollar flyby.
Solar system, telecom off net for 1. Copy, telecom.
Things continue to go well in Cassini Mission Control. We're approximately 33 minutes from burn start. There's our flight director, Julie Webster. This is one person we hope to not hear from tonight. This is System Fault Protection Engineer, Paula Morgan. And if we hear from fall protection, that means we've had some sort of anomaly on the spacecraft. Doug Johnson, our radio science and SOI communicator, he's the one reporting most of the events we'll see tonight through that Doppler signal.
Also on console is Jan Berkeley. She first worked at JPL as a college intern. Now she's a key member of the Cassini team that creates the computer sequence commands that operate the spacecraft.
We would run them, make sure that there were no problems with that. If we needed to do testing, we would schedule testing. We were the ones that actually sent them to the spacecraft. And then we watched them clock out. That was the tense moment, was not pushing the button, it was waiting for it to come back. That worked. And Saturn was so far away that it would take 3 hours just to get there and come back.
Current speed of the Cassini spacecraft, 22.2 kilometers per second, which is just under 50,000 miles an hour, and increasing as Saturn's gravity draws us in. That's Shin Hu, our SOI systems engineer. Shin has eaten, breathed, slept, and lived SOI for many years. Tonight is his big night.
All stations on net, SOI systems. Just an advisory, we're coming up on the time that the critical sequence will initiate the turn to the SOI burn attitude. The burn command will be sent at 7:35 p.m. local time. Flight Director, SOI systems, all subsystems report the spacecraft data is nominal and ready to support SOI.
Okay, I copy that.
SOI comm, Flight Director.
We're waiting.
Copy, telecom.
A JPL tradition has begun, starting in the back of the mission support area. This is the consuming of the lucky JPL peanuts. Doug Johnson just reported a signal. We've survived the ring plane crossing through the F&G rings. One hurdle down, one to go with the start of the burn, a mere 9 minutes away.
Ace Flight Director on FSO Court.
Go ahead.
Are you still tracking Canberra on B2?
That's affirmative.
Let's go ahead and switch Canberra over to B0.
Correct.
Go ahead, Nav1.
We can confirm that we're receiving one-way data from the DSN.
One-way Doppler from DSS 14.
Yes, that's affirmative.
Navigation can also confirm we're receiving the Doppler data. We've been able to verify that the turn to the SOI burn attitude is complete. We're approaching 2 minutes before the SOI burn. Hopes and dreams of thousands of scientists and engineers are resting on the next few moments. So Godspeed, Cassini-Huygens. May we see you in orbit.
We're going to drop it, but I guarantee it.
On the Doppler display, what we're looking for is a turning of the corner to start to follow that line down to the lower right. And that's our indication the burn has begun.
Yeah, we're not there. We're probably
Flight SOI com.
Go ahead.
We have a Doppler signature consistent with engine turn on.
Lots of high fives and celebrations in mission control. Congratulations, all of you that have worked so hard for this moment. One minute down, about 96 minutes to go. We're continuing to follow the nominal predicted curve on the Doppler. So the fact we've turned the corner means the engine has started. The fact that we're following the line means we're getting the right thrust out of the engine. So more good news for the Cassini-Huygens spacecraft.
Way to go. Way to go.
There's now 90 minutes of waiting until Cassini's engine is to stop firing. The lull in the action affords a rare opportunity to give members of Congress who are on hand a very up-close and personal tour.
This is sort of what we expect to happen to the signal. We're trucking along here now for first grade. We're expecting the signal to drop that fast.
It's a moment to witness history in the making, and as politicians well know, to take advantage of an excellent photo op.
Right on critical. The yellow is the prediction.
It's 7:42 p.m. in NASA's Cassini Mission Control. The next thing we'll look for is an occultation by the A-ring around 8:05 p.m. Pacific Time local. At that time, we'll see an increased noise in the Doppler signal, similar to the increased noise there at the far left of the Doppler plot. And our final scary moment of the evening will be to make sure to get the burn shut down, the history-making day for JPL, NASA, and the world.
Flight, SOICOM.
Go ahead, SOICOM.
We've hit the A-ring pretty hard.
More good news from SOICOM there. The frightening-looking change to our Doppler data is totally anticipated. This proves that Saturn's A-ring is where we think it is, and the Cassini spacecraft is where we think it is as well.
We're continuing to track a 2 to 3 dB signal with occasional outages through the A-ring, and we expect to see a nice strong signal when we hit the Cassini division coming up.
Copy, that sounds good.
As we see, we're approaching the B-ring, and we must remember tonight everything happening at Saturn occurred an hour and 24 minutes earlier due to that pesky speed of light, 186,000 miles per second, their interplanetary speed limit, if you will.
Go ahead, SOICOM.
After a brief peak up to 11 dB, we have now exited the Cassini division.
Copy.
What just happened?
They just announced that we are now a captured object around Saturn. We are now an orbiter. They just announced
first in history around Saturn.
There you go, first man-made orbiter around Saturn. Voyager, eat your heart out.
SOI Systems, this is contingency. SOI Systems.
Closest approach is just a little over 2 minutes away. And given that, it's probably about time for our Saturnian weather forecast. Predicted temps today, minus 226 degrees Fahrenheit or minus 143 degrees Celsius. Winds of 1,100 miles per hour or so. Chance of helium rain inside the interior, 100%. Hurricanes the size of the Earth. Cassini would do well to batten down the hatches. Closest approach is upon us with a speed of almost 69,000 miles per hour, and the speed has started slowing.
Flight, SOICOM.
Go ahead, SOICOM.
The Doppler has flattened out.
Okay, we have burn complete here for the SLI orbit insertion burn. Congratulations continue in mission control. The high fives begin in the back of our mission support area. I'm just hearing a report from radio.
You did great.
Thank you.
You did great.
My pleasure. To our Lockheed Martin propulsion engineers. Did a wonderful job tonight.
Knowing that it survived and was there and we were ready to get to the meat of the science and get these great images, it was a wonderful moment. The voyage begins. We made it. Like, we did it.
Fantastic job.
What's that?
Now I'm going to put your E-cap in.
I was just informed by my management she'll put my performance evaluation in. I'm glad she waited till our success tonight.
That's the why. That's the why. We're in.
That's the why.
We're there.
So there's this amazing elation, and then almost immediately a crash, just because we were exhausted and tired. But I couldn't sleep, and so I stayed in the MSA, and the images of the rings were playing back. And slowly people started to gather around these images, which no one had seen. Close-up images flying right over the tops of the rings.
Or a cosmic ray.
And they were just goosebumps. It's a memory I will never forget.
This has got way more ringlets, little pieces in it.
Until now, the mission has been mostly the province of engineers. With these first ever close-up images of Saturn's rings, the shift to science begins in earnest. And there are hints of major discoveries ahead from what already can be seen.
I don't think you have to be a ring scientist to imagine what last night was for us. It was beyond description, really. It was mind-blowing. It was every adjective you could think of. I'm surprised at how surprised I am at the beauty and the clarity of these images. They are shocking to me. The spacecraft allows us a very steady platform. This machine, you turn it, you point it, and it stays there. It's like a tripod in space. Anyway, I think ring scientists are going to have a field day. So, thank you. Wow.
Cassini's arrival coincided with a time when the planet was well lit by sunlight, providing extraordinary views of the rings.
Saturn plus the rings span about 250,000 miles, and they would fit in between the Earth and its moon. And yet, for all of its wide expanse, the rings themselves are paper thin, only about 10 feet thick. If you could scoop up all the ring particles, they would be less massive than one of Saturn's small moons named Mimas.
From a distance, the rings cast off a sense of serenity, but they are as complex and chaotic as they are beautiful. For they are made up of countless numbers of disorderly objects of different sizes and shapes. This is a simulated image showing particle sizes found in different regions of the rings. The color purple represents where there is a preponderance of objects smaller than 2 inches. Particles in green are about 1 inch in size. The bluish bands are still smaller. The white bands are dense regions that radio signals were unable to penetrate. This false color image highlights what can be seen in the ultraviolet. The turquoise colors represent water ice. The red colors are a different kind of particle. Uncertain as to what it might be, the scientists decided to name it dirt.
Cassini was also able to measure the temperature of the ring particles, and the rings that had the most dirt or pollution were slightly warmer than the bright, icy rings.
And despite being made of mostly cosmic dust and ice, the rings contained some structures as large as a house, and as scientists discovered to their astonishment, even transitory mountains.
There was a unique moment in the Cassini mission where the sun was edge-on to the rings, and that allowed us to see anything that would stick up above or below those 10 feet thick rings. And lo and behold, we found what looked like mountains casting huge shadows on the rings. And it turns out that the rings of Saturn are not like just individual particles, but a lot of these particles stick together and grow into larger and larger particles. But these clumps of particles are ephemeral. They don't last for a long time. They can be broken up and then reformed into new particles.
Saturn's moons and smaller moonlets also influence the rings. Even orbiting rubble piles hold a kind of sway. Altogether, they help shape the boundaries of Saturn's rings, herding in particles that might otherwise rain down in a torrent on the planet or escape into deep space. Meanwhile, particles from some of Saturn's moons are constantly shedding off, helping to preserve existing rings or creating new ones. Among the unexpected discoveries within the rings were these propeller-like objects.
Propellers are these largest clumps of ring particles, and they get big enough so their gravity wants to push apart the rings and open up a gap. And then there's not quite enough gravity to open it up all the way. And so you see these little propellers sprinkled throughout the rings, especially in Saturn's A-ring.
A mystery dating back to Voyager was the appearing and disappearing of ghostly spokes. Cassini determined their cause: electrostatic charges that lift up dust particles where they levitate for a time above the rings. There remain two fundamental questions lacking definitive answers. The first is knowing how the rings came to be.
So many things about the rings are unexplained even now. There are a lot of ideas for how Saturn's rings initially formed. One of those is that perhaps the rings formed from the material that was left over from when Saturn formed. So if that's true, then the rings are old as Saturn itself. Other ideas say perhaps an object, maybe a comet or a meteor, came in too close to Saturn, was torn apart by Saturn's gravity, and then created the rings. Or perhaps a moon wandered too close to Saturn and was torn apart. And so then the rings could be as young as maybe only 10 or 100 million years old.
Along with determining the origin of the rings, understanding their fate is also an unanswered question. But the adage that nothing lasts forever likely applies even to them.
As micrometeoroids continue to bombard the rings, and some of the innermost particles fall into Saturn and actually water the planet, the rings are getting lighter and lighter with time. And so perhaps in another few 100 million years, Saturn's rings as we know it might be gone. Maybe we'll be left with narrow rings like we see in the Uranus system.
And one day, long from now, Saturn's glorious rings might disappear altogether. One more reason to enjoy them while we can. Next time on JPL and the Space Age, Part 2 of Triumph at Saturn. With Cassini safely in orbit, science takes center stage. Beginning with the dramatic descent of the Huygens probe to the surface of Saturn's moon, Titan.
We knew Titan was a tough target, was going to hold its secrets tightly, and so we designed this mission to hit it with everything we've got.
In the years that follow, one unexpected discovery after another will be made, earning this international mission accolades from around the world.
Science is about what is, and engineering is about what can be. The Cassini-Huygens program has demonstrated the best of both. The number of your new discoveries is nothing short of amazing.
I would say Cassini's discoveries fundamentally altered the way we look at our solar system. Around one planet, we find two moons that could potentially be habitable, have the key ingredients to support life.
I have more than a passing interest in Saturn and its family of moons. When Cassini was launched, we knew of only 18 moons. I understand it's now 60 and counting. I can't resist the temptation to say, my God is full of moons.
Triumph at Saturn, Part 2, next time.